Welcome to Study Loop.
Given the function, if we want to find the horizontal distance from the firing point that is a maximum, that's going to be at the vertex, and we can find that vertex with opposite b over 2a. In this case, the b value is the coefficient on x, which is 1. Then it's 2 times a, which would be negative 32 over 100 squared, because that's the coefficient on x squared. So that'd be negative 1 over, I'm going to go to a calculator here, 2 times negative 32 over 100 squared is negative 4 over 625. Negative over negative is positive. When you divide by a fraction, it is the reciprocal, so it'd be 620 over 4, 625 over 4, or 156.25. So the horizontal distance would be, when we're looking at this projectile maximum, the horizontal distance would be the x-coordinate, so it would be 156.25 feet. The maximum height would be, if we substitute 156.25 in for x, so that'd be h of 156.25. Let me go back to the calculator. And so that would be negative 32 times 156.25 squared over 100 squared plus x, which is 156.25, 78.125 would be the maximum height. At what horizontal distance from the firing point will it strike the ground? That would be when h of x is equal to 0. And we could use the quadratic formula here, which is opposite b, where the b value is 1, plus or minus the square root of b squared, which is 1, minus 4a c, which is 0, all over 2a. Well, since c is 0, because there is no constant, this is all 0, and the square root of 1 is 1. And again, 2 times negative 32 over 100 squared is negative 4 over 625. And so we have negative 1 plus 1, which is 0, or negative 2 over negative 4 over 625, and negative 2 over negative 4 over 625 is 312.5. For C. Now if we actually graph this function, negative 32x squared over 100 squared plus x, and we want to graph it to at least 350. So let me change my x to go to 350. And we'll have to change our y's. I think maybe I'll go to 200. Yeah, that's plenty. Actually, 100 will look nice for the y's. So to verify, that's D. Verify B and C. Well, we said in B that the maximum height should be 78.125. Yep, that checks out. And it hits the ground at 312.5, checks out as well. When the height of the projectile is 50 feet above the ground, how far will it have traveled horizontally? Well, if we went back and solved, we could set this equal to 50 and solve. Since I've got the graph here, we could just graph y equals 50 horizontal and find their intersections. So on the way up, it'll hit 50 after 62.5. feet, and on the way down at 250 feet.